Hello, this is a not so short video presentation on the real numbers. In the study of mathematics, it is important to differentiate between different types of numbers. There are real and imaginary numbers. At this point in time, we are only focusing on real numbers. You need to learn everything there is to know about these real numbers, because when I say integers, rational, irrational, etc., you need to know what I'm talking about. There are 5 different types of real numbers. You will learn to state the different types of numbers and explain why they belong to the set they do, to state an example of each type, and you will learn to identify and state all the different types a given number is. So if I ask you, for example, what is an integer, you should be able to tell me, give me an example. And if I ask you what is 2/3, what kind of number, you should be able to tell me that. All the numbers we are going to talk about today are real numbers. Every single number is a real number. We will talk about natural numbers, whole numbers, integers, rational, and irrational numbers. Each type of these numbers is also a real number. The natural or the counting numbers. When you were little, you learned how to count. What did you learn? 1, 2, 3. You counted on your fingers, you counted how old you are, you counted how many objects there was. These are the counting numbers because that's how we count, or natural numbers because it's just natural. The natural numbers are denoted by the letter N. This is a standard letter that we use. The set of the natural numbers are 1, 2, 3, 4, ... For a set of objects, we use the braces. What does the ... mean? It means it goes on forever and ever and ever. Natural numbers are also real numbers. 5 is a natural number, and it's also a real number. After you were taught to count, or at least after you began to learn how to count, you got your mind messed with a little bit. What number did we add to the natural numbers? You learned how to count 1, 2, 3, 4, 5, 6, 7, on and on and on, but then we added something. Yep, we added a 0. The 0 has a hole in it. It's an easy way to think of the whole numbers. The whole numbers are the set 0, 1, 2, 3, 4, ... The only difference between the whole numbers and the natural numbers is the number 0. The whole numbers are sometimes denoted by the letter W, although there is no official symbol used, unlike the natural numbers. It's also easy to remember W since whole starts with a W. All natural numbers are also whole numbers and real numbers. 5 is a natural number, it's a whole number, belongs to that set, and it's a real number. In middle school, probably in middle school, at least for me it was, we added a lot of new numbers. What were they? They really messed with your brain. No, not negative numbers. The integers are the whole numbers and their opposites. In other words, 0, it's a whole number, so 0. 1 and -1, -1 being the opposite. 2 and -2, 3 and -3, etc. The integer numbers are the set ... -4, -3, -2, and so on, 2, 3, 4, dot, dot, dot. It goes in both directions forever and ever, for infinity. The integers are denoted by the letter Z or the letter I. Z based on the German word for integer, I most likely because integer starts with an I. All natural numbers and whole numbers are also integers and real numbers. 5 is a natural number, a whole number, a real number, and also an integer. 5, as you can see, wears many hats. -5 is an integer and a real number. 0 is a whole number, an integer, and a real number. About the same time we were torturing you with negative numbers, we also added fractions. Rational numbers are any number that can be written as a quotient. In layman's terms, a fraction. A quotient of integers. 2/3 is a rational number. 2 is an integer, 3 is an integer. 5 is also a rational number. Why? 5 can be written as 5/1. Again, a fraction of integers. 0 likewise, 0/1. Decimals can also be written as fractions. 0.23, if you remember, is 23/100ths, our quotient of integers. 0.23 repeating is also a rational number. 0.23, 23, 23, on and on and on, where that pattern repeats, can be written as 23/99ths. We'll learn how to do that later on. 0.2357 dot, 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 is not a rational number. It does not repeat. We can't write it here like we did this. It's not a rational number. Terminating decimals are rational numbers. 0.23 is terminating as it ends. All terminating decimals are rational numbers. Repeating decimals are rational numbers. 0.23 repeating is repeating as 23 repeats forever. And again, we will learn how to find out what fraction that is. Non-terminating and non-repeating decimals are not rational. 0.2357 is not dot, 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 dot. I can't forget the dot, dot, dot. Is not a rational number as it neither terminates nor repeats. Since rational numbers are numbers that can be written as a quotient, we use Q for quotient to denote the set of integers. 5 is a natural number, a whole number, an integer, a real number, and a rational number. -5 is an integer, it's a rational number and a real number. 2/3 is a rational number and a real number. Likewise, 0.26 is a rational number and a real number. Our last set is the irrational numbers. Irrational numbers are numbers that can't be written as a quotient of two integers. We commonly think of irrational numbers as non-repeating decimals. Pi is probably the most well-known irrational number. Square root of 2, square root of 3, etc. are also irrational numbers. You can see that if you plug it into your calculator, the decimal goes on, does not terminate, and does not repeat. Square root of 4 is not irrational. The square root of 4 is equal to 2. It's a whole number. It's a natural number. Irrational numbers do not have a letter to denote the set. There are ways to show this, but it's beyond our scope in this class. 5 is not an irrational number, as it is rational. All real numbers are either rational or irrational. This is a very important point right here. Every number that we're going to deal with, for now, is either rational or irrational. Pi is both real and irrational. Square root of 2, real and irrational. Now you should be able to say, I can state the different types of numbers and explain why they belong to the set they do. I can give an example of each type, natural or counting, whole, integer, rational, and irrational. I can identify and state all the different types a given real number is. Thanks and have a great day. You guys rock. Go Pack Go!